This is my 21st century science and technology final project. So, first of all, tenderizing solutions are enzymatic solutions that help break down proteins in the meat in order to create a more tender steak. In this document, I will show the relationship between how much percent of a substance which tenderizes meat do you need to keep the most moisture and the most juices inside a steak. This is my research question. What is the relationship between the percentage of papaya that you have in a solution to the weight of a cooked flank steak? And in my experimentation, I did 3 primordial steps. The first one was to make 10 different solutions. Second one was to marinate them. And third one was, of course, to cook them and weight them. But here is a more in-depth view of this. First of all, you need to cut all your flank steak pieces all from the same piece of steak or from the same cow in order to keep as much things like the same. And we have to cut them each on the same shape and approximately the same size because we want results that are coherent, right? So after that, we make 10 solutions of papaya or tenderizing solutions, each one with a 20% increase of papaya in it. So we'll start from 0, which would be just plain water, to all the way to 180% of papaya in the solution. After that, we're gonna marinate all the 30 pieces of steak in the solutions. We're gonna put 3 pieces per bag or per container, and we're gonna marinate them for 2 hours. After those 2 hours have passed, we will proceed to cook. Remove any tenderizing solution left on the steaks, and then we're gonna cook preferably on a sous vide machine, since this machine can keep the temperature not varying, but it can keep the temperature the same throughout the whole process. So we're gonna cook the steaks on the sous vide machine for 2 hours, and after that we're just gonna wait. So here's my data that I got. We can see that all the way to the left, we got the papaya percentage in tenderizing solution. So that is not how many grams of papaya there were. You can see that data on the second or third column right there. And it's basically how the percentage between papaya and water, which is what my research question is focusing on. So we got that, and we got the initial weight and final weight of the steak. And because of these values, we made what I made was a proportion of final mass loss, which is important to note because we want to know how much mass does each percentage of papaya in tenderizing solution make. And so in this graph, we can see here all the different values that we got. The blue ones, and some of the blue ones are over the red ones, but the red ones are just the averages of these blue values. We have 30 in total. We have 30 data sets, and the red ones are just 10 because those are the average of each group of 3 steaks, right? And so you can see here on the x-axis we have the papaya percentage in solution, and over here we got the average proportion of final mass loss. And you can see that the y-axis doesn't start off at 0 because otherwise it would be it would be difficult to see the different relations that each, how much each value varies, right? So be sure to weight the steaks, because that's what you're looking for, right? Making the experimentation, you should make sure that you weight the steak pieces. And so here is my data analysis. I made a line of tendencies since I had a really great graph showing basically how high and how low the data sets went, and also the averages. So you can see that this line of tendency goes throughout the whole graph, not going over most of the data values, data sets, and not going under any of the data sets. Yeah, this is a polynomial. You can see it right here. And what I did was I put my data values on Excel, and I just hit the line of tendency mode. And I experimented with linear and this polynomial and more so bigger polynomial functions, right? But this was what I think the least complex and the most accurate, because I could get a longer function, but it would be very, very complex, and it would be closer to, the R would be closer to 1, R squared, the coefficient of determination. That would be closer to 1, but I think it's best to keep it more simple, even though it was more accurate. I tried the linear type of function, which sort of made it with a really slightly positive slope, but it wasn't as detailed as this. And I think this just fits the data better. And what did I get from this? Well, in conclusion, my hypothesis was that around 60% the data, the weight of the stakes would just stop from changing, right? It would just get around the same thing, and the major changes would be around 0 to 60%. But as you can see here, the most interesting point is around 100%, where we can see a lot of change in value, from going from loss in a very consistent mass loss to a actually lower percentage of mass loss. And we can also see that the point at which the least uses are lost, or the point at which the proportion of mass loss is at its lowest in the graph, is around 160%, which I think we can conclude that around 160, 140% of papaya in a tenderizing solution is what you would want to have if you were to have a restaurant, for example, and you wanted to tenderize your steaks, but you wouldn't want to lose any juices. And so that's it. I hope you enjoyed it, and I'll see you next time.